Good evening, everyone. Welcome to Sky Observers Hangout. My name is Michelle. Welcome to the Dome Observatory here at the Adler Planetarium. We are so delighted to have you with us here today. I've got a friend with me.
Yes, my name is Hunter, public observing educator here at the Adler Planetarium, and we are so excited to be joining you for today's episode of Sky Observers Hangout. Joining you live here in the Dome Observatory. You can see the familiar telescope behind us, as well as a little sneak preview over there of what we'll be looking at tonight. So we've got a few friends here helping us in the chat tonight as well. If you see the Adler Planetarium's account highlighted in yellow, that is our friend Jennifer. She'll be helping chat moderate tonight, as well as passing off any questions or comments that you have to us. So you'll see her in the chat. And then if you see a name with a blue wrench next to it, that'll be our astronomer friend Geza, who will be helping us answer the let's say particularly difficult questions tonight. Maybe questions that require more specific numbers that we need a little extra help with. So thank you to both Jennifer and Geza for joining us tonight.
And by the way, you may have noticed on our title slide, our intro slide, we had a different date. We originally scheduled this program to happen in January. It was below zero that night, so we moved this to February, so that's why that happened. So we wanted to point that out because, as much as we wanted a clear sky that night, we didn't really want to be in here when it was below zero, but it is much better tonight.
Yes, you know what? We got so lucky though. We've got what are still clear skies outside right now. Hopefully we can carry those through the rest of the show. It's not too chilly out here. We're both well prepared. We've got our electric hand warmers. Shout out to my mom if you're there. She got me these for Christmas. So we're good and well equipped for tonight's show, right?
Exactly. Well, if you are new to Sky Observers Hangout, this is our place to gather together to nerd out about the sky. And if you want to just sit and watch, that is perfectly fine. We love that you are joining us here tonight. If you want to interact with us, do that via the chat. Send us questions. And if it's questions that Geza can answer, awesome. If it's questions that we can answer, even more awesome. And so first things first, let us know where are you watching from. So put in the chat where you happen to be right now, and we will get some of those indications from Jennifer behind the scenes. So
yeah, and whether you be joining us from here in Chicago or from afar, one way that you can always stay connected with the planetarium is here on our YouTube channel. Not only our live streams, but lots of other great content that gets posted here. So make sure to hit the subscribe button down below if you really enjoy the show today and want to keep getting some awesome astronomy content in your inbox.
And if you want to visit, yes, we are open for visits. So Jennifer is going to put a link to purchase tickets there in the chat as well. And we've got lots of Illinois folks. Chicago, Mokina. I think we know who our Mokina friend might be. Hi, Bob. Oak Park, Naperville, Arlington Heights, Downers Grove. Oh my goodness.
They're coming in fast. We'll give everybody else a little bit more time if they want to post their responses. But thanks for joining from all over the area. We're so glad to have you here today for what should be a really exciting show. And with that, should we get on to what our topic is for tonight?
It is.
Do you want to do a little intro for what we're going to be looking at today?
Why am I so excited? Because it's clear out. So we are actually going to show you live telescope views. And so we'll do a little preview. We're going to look at some stuff in the constellation of Orion. And I just dropped one of my hand warmers. There we go. I call it testing gravity. It works right here. We're going to look at some stuff in the constellation Orion, starting with the birth of stars.
Yeah, so we're taking a look at some different objects in this, what I think is a pretty well-known constellation here in the sky, right? One that lots of people can point out. But we want to dive a little deeper, take a closer look at some of these objects, and then see what we can learn. And what we might notice is that, I think we'll learn a lot about, maybe the birth, the death of stars, their kind of life cycle. So tons of really interesting stuff today, but we might as well get started with the beginning, right? With that birth, yeah?
Absolutely. We're going to switch the view. We're going to show you a live view from our 24-inch telescope. This really is live. This is not a picture that we snapped earlier. What you might notice is the view might jump around slightly. And that's because we've got a little bit of a breeze tonight, and that's catching hold of the shroud that we have around the telescope to help light from getting in from the sides. So you might see that. You might see the view go a little bit in and out of focus. Again, it's because we're taking a longer exposure image, and so this is gonna get a little bit more of that movement if the wind grabs a hold of the telescope a little bit and moves it slightly. That can happen. So you may see that. But this really is a live view. We've got a camera that is right here.
There you go.
Right here. And so
A little blue light blinking up there
Yep.
is the camera part.
Exactly. And we are looking at the Orion Nebula, M42. Oh, by the way, can we say hi to a couple more people?
Yeah, so we see Peter from New York City, and then also hello Savannah in Cincinnati. Nice to see you, Savannah. Love the support.
So it's great that we've got folks not just from the Chicagoland area. We love knowing you're watching us from other places too. So continue to let us know where you're watching us from. So the Orion Nebula is a stellar nursery. You're seeing a cloud in the sky, a cloud of gas and dust. And this is where stars have formed, and some of those stars are lighting up the dust and gas, so we're able to see this really magnificent object. It's called M42 because it is the 42nd fuzzy thing that Charles Messier cataloged. And so he numbered them along the way. So this is the 42nd thing on his list. So
now,
pretty awesome.
You know, there's a lot to unpack there, I think, with the Orion Nebula.
Yep.
It's a really interesting object. It's one that, you know, has provided, you know, not only people that want to look at beautiful space objects a lot of, you know, enjoyable times, but also has provided astronomers with a lot of really invaluable knowledge regarding this kind of star formation and things. And that's because this is, you know, as far as nebulae go, this is a really big one. It's a very bright one from here on Earth, right? You can even see the center of this just with the naked eye when I was out there earlier. And when we're looking at the bigger constellation view, we'll point out where it is later in the show. But you know, there's all these things that make this really interesting object to lots of people. And as soon as we, you know, had telescopes, we were starting to see a lot more detail here.
Actually, we can point out real quick using the software for moving the
so
telescope.
true, yes.
Let me switch the view. We are looking right there. So the green circle with the yellow circle, that indicates where the telescope is currently pointed. So you'll see the constellation of Orion right here. And we've got the stars of his shoulders, Betelgeuse and Bellatrix. We've got his belt right here, those three stars. We've got his knees, Safe and Rigel. And so right in between, almost in between the belt stars and Safe, we've got the Orion Nebula right there.
In a dark enough location, you'll see maybe three little, well, what might look like stars to you, to your naked eye, right? Kind of lined up there together. We call that Orion's sword, right?
Exactly.
And so, while it might look like three stars, one of those little points of light that you can see with your eye is actually this big stellar nursery that is producing all of these new stars. Now you might be wondering, okay, you said stellar nursery, you know, I don't see anybody rocking a little baby bed here or anything.
No.
Like, how the heck is this happening? You know, okay, we've got all this big, you know, gas and dust cloud. How do we get from big clouds to stars, right? These big, powerful, bright objects.
Well, it is a really amazing process. It takes quite a while. So this giant cloud of gas and dust. The dust is basically little bits of, you could say, bits of rock. It's like a little, just tiny smoke particle-sized bits. That's the dark stuff that you see. So it looks like no stars right here. That's actually dust, or dust is right up here. Now this glowing stuff, that's the gas, and this pink right here especially, that's glowing hydrogen, and hydrogen makes up probably most of that cloud. And so this big cloud, something causes bits of it to start spinning and collapsing. So the material starts to collapse, it spins, it collapses some more, it spins, it collapses some more. And if the stuff in the middle collapses enough, then you get energy starting to be created by the star. It gets hot enough and dense enough to create its own energy, and you have a star. And so that's what's happened in this particular cloud, where you've got thousands of stars. You can see several of them here. There's actually a lot more that aren't as easily visible in this view. By the way, one of the questions that we got kind of is a little apropos to what I just said.
It's a good question.
Yeah, Mark asks, how long is the exposure to get this image? And actually,
you can just make out the settings if you point it over there. It looks like we've got, what, 567?
Milliseconds
there.
So about half a second exposure, but I also have the, it's called gain. It's basically electronic brightness. So it electronically accentuates the brightness of the image. It doesn't collect any more light, gain doesn't. It just takes the light that the telescope has collected and put onto the computer chip in the camera, and it artificially bumps that up a little bit, just so you can see it a little bit more. And actually, I can show you that.
Yeah, we can adjust some of those settings.
So taking the gain down, see?
And you know, one thing I notice when you adjust the gain is you lose a lot of the detail in like the nebulosity in those gas clouds.
Yeah.
But you really don't lose a lot of brightness in these big bright stars that are in view, right?
Right, yeah.
And then, you know, whereas the opposite would happen if we were to increase the exposure time a lot. Sure, those gas clouds would get brighter, but all of those stars would get quite a bit brighter too and end up really washing out the image.
Correct.
So since we have a nice big aperture, we don't have to have a super long exposure time.
Correct.
And so we're able to get this pretty crisp view, even though it's, you know, a live view of it.
The 4 stars in the middle, these are the ones responsible mainly for lighting up this dust. These are called the trapezium stars. That's because if you take a look and you remember back to geometry class and you asked yourself as you were sitting there in junior high or high school, when am I ever going to use this information? This is where you use it. The 4 stars in the middle are in the shape of a trapezoid. And so,
okay.
There you go. That's where you use this information. So, but those are the 4 that are, they're big, they're bright, they're hot. And so they're lighting up that gas, kind of like almost like a fluorescent light bulb. By the way, hello to Betty from Florida and Deb from North Carolina and Steve from Ohio. Thanks for joining us. So again, for those who are just joining us, this is a live view from the Adler Planetarium's Dome Observatory. We're looking at the Orion Nebula in the sky. So if you want to go outside and see Orion in the sky, why don't we show you real quick on how to do that, because if it's clear out where you are and it's dark out where you are, you can go outside and see this thing. We can see it.
Absolutely. We can see it
Chicago.
from right here.
Yep.
So I'm going to switch us over from that live view through the telescope to this. So this was this is a screen grab from a program called Stellarium Web. Jennifer will post a link to that website in the chat for you. It's a wonderful open source kind of like I guess whatever sky viewer or something like that.
Yep.
And it's a really great way to know what is up at any given time in your location. You can get all kinds of wonderful information from here. So I took this screenshot of this kind of big sky view of our view here tonight in Chicago to point out a little bit of, you know, how you can find Orion in the sky. Now, many of you might be familiar with this constellation. It's one that many people are able to pick out in the night sky. But for those of you that are a little newer with this, I think one thing that always helps me when looking for Orion is searching out for his belt. I think his belt is so distinct. You can see it right here in that image, those 3 stars lined up real close together. They're very bright, and for how bright they are, they're very close together in the sky. So that really helps a lot. Now, as we get a little bit closer, you'll see that belt, and then the next ones you'll want to look out for are those 4 corners. Like Michelle was mentioning earlier, those 4 corners will be very bright stars. Rigel and Betelgeuse are both in the 10 brightest stars in the night sky here. So.
I like to think of Orion as a sideways bow tie. So if it's dark out where you are right now and you're in the central time zone or the eastern time zone, go outside, face to the south or southwest, look about halfway up in the sky, there it is.
Yep, you'll see him there. You'll see another big bright dot off to the right next to him. That'll be Jupiter tonight.
Yep.
And now you'll see in this that there's also quite a few extra stars included in this constellation beyond those base 7 that we're talking about, right?
Yep.
Now some of these might be a little harder to spot depending on your location. You know, here in the city, some of the other stars might be pretty difficult to see. We mentioned that sword from earlier. Some other ones that you can look out for are the 3 little stars of Orion's head. I like what you said earlier, Michelle. Kind of small stars. They're not very bright. Yeah, sorry, Orion.
Yes, dim stars. He wasn't a very bright guy, so yeah.
Known more for his brawn, right, than his brains.
Exactly.
Because you might see, alongside the sword, we've got, his shield, his big club being lifted into the air. So lots of different symbols indicating his strength here, right?
Exactly.
And we'll take a look at some different paintings of the constellation later in the show. So we'll get a better idea of that.
So why don't we go back to that telescope?
Yeah, let's get back to the telescope view.
Actually, I'm going to look real quick and see if I have to move the roof at all. So let me just check.
Roof looking okay?
And I do. So.
Okay.
All right.
Apologies if this is a little loud.
So I need to move the roof. I don't think you can see. Well, you kind of can see it a little bit.
Let's see right
about
there. That's the roof.
There we go.
So you'll see it spin a bit. You can see it moving up there a little bit in the background.
Okay, good enough.
So our telescope, as you can see behind us, is on like a big mount that allows it to track the objects that we're looking at. That's why the nebula has not moved out of view since we've been pointing at it the entire time. The roof, a little bit older, so that's manually, well, I guess not manually powered. We don't have to get up there and push it, but we have to press the button manually.
Not unless it gets stuck, so yeah, which has happened in the past. That's okay. So the view that we've got, again, this is live. This is an image that's constantly refreshing every half second or so, a little over half second, to take this particular image. And so if you're seeing the view getting a little bit fuzzier or a little bit clearer, that's because, as I explained earlier, there's a little bit of a breeze tonight, and it's grabbing a hold of the shroud that's around part of the telescope, and it's kind of moving the telescope a little bit, but also that moving air is affecting the light that we're getting from the stars. So they're gonna look like they're jiggling a little bit, especially for taking a longer exposure image.
Right,
So,
if little clouds pass in front too, there's very much a possibility of that tonight, but I think it's a great mention to talk about the atmospheric conditions and how important those are in astronomy, right?
Oh, very important. We took some sample images just in case we got cloudy weather tonight. We took some images a few weeks ago. They were horrendous.
They did not look this good, I will say.
No, they did not look this good.
We can show them this one after.
Yeah, actually.
Post-editing.
Yeah, why don't we go show it to them?
So this is with a little bit of post-processing, just kind of up in contrast, trying to get some of the brightness out. You can see how different. This is our current live view. This is also just a single exposure, trying to bring out some extra detail. It was much more difficult to get a clear view that night.
Yeah.
So I'm glad that this is the view that we're dealing with.
Yeah,
instead,
it was
right?
a lot windier that night. So the jiggliness of the stars, we call that seeing. It was terrible. James has a great question. James wants to know if we're using any filters. And the answer is no. This is just the telescope and a color camera. That's it. No filters tonight.
So what I do want to add, great answer to James's question, but for anybody in the chat that might be wondering what James is talking about with filters, this is in reference to filters that are often used in astronomy that actually go onto the camera portion. And so when we're taking a lot of astrophotography, these big images and things, we will actually use black and white cameras most of the time. They'll pick up the most amount of light, right? They're gonna be in the most crisp detail that we can get, but we still want the final images to come out in beautiful color, right? Be able to see all that red, hydrogen, and things that are in our views. And so we can utilize filters to do that. You might take some images with a red filter, take some images with a green filter, take some images with a blue filter, and then in post-processing you can combine those together. It gives now color to this black and white view, while still, giving us the maximum light collecting capabilities.
In terms of astronomical data, if we're collecting data to do some sort of research, a color camera is okay. You lose some of the information if you do that. That's another great reason for using the monochrome, the black, white, grayscale type camera. So if we were taking data, we would use the grayscale camera, because we wanted to show you the true color of, or at least pretty close to it, of the Orion Nebula. This is real. We are not, the only thing we're doing is taking a half-second long exposure and bumping up the artificial brightness just a little bit. That's it. That's all we're doing to this. This is spectacular.
Now, there are some additional filters that people often use, like especially with smaller telescopes and things, to help bring out some of the detail in the gas clouds and things. These filters that are tuned to very particular wavelengths based on the light that these different gases emit. Today we're opting mostly just for aperture,
right?
To give us a good view. So thank you, 24-inch telescope. Yeah, thank you, big telescope.
Exactly.
That really takes a lot of that hard work out of it. So great question, James. And actually, I think that segues really well into, we're talking about all these different wavelengths of light that are being imaged, how they're combining them together. And I think, while talking about post-processing, that makes me want to take a look at some other images of the nebula to really get a better idea of what we are looking at here. So one thing I was noticing looking at this is you might see right next to the nebula, there's 3 stars kind of lined up together. And you might be like, oh wow, look, it's Orion's belt, right? Because they are in a very similar shape, right? So what we are looking at is much, much more magnified than the kind of field of view that you would need to see the entire Orion's belt. So these are 3 different stars that just happen to be in the same area. So to kind of exemplify this, I wanted to show not one of our images of the Orion Nebula, but probably the most famous one. If any of you have seen a picture of the Orion Nebula, it's probably this one, taken by the Hubble Space Telescope, right? And in this, I mean, nothing we can do here at the Dome Observatory is going to compare to the billions of dollars that have gone into Hubble, right? Beautiful, beautiful images, tons and tons of pictures stitched together, many exposures, tons of processing going on here. But really the reason that I was sharing this picture today is because we can now overlay kind of what we're seeing today. So this is with that picture that we took, was it 2 weeks ago? A couple of weeks ago.
Yep.
And you can see a very similar kind of, at least field of view to what we're seeing today. You can see we're really just seeing the very central core of this big gas cloud, rather than this entire big nebula. So it is a huge, huge object in the sky.
Yep, and the Hubble Space Telescope also only sees a tiny portion of the nebula at a time. So even the Hubble image is going to be lots of images all stitched together.
Exactly.
And also processed to bring out the really amazing colors and everything. And so that's it. There's a little bit of artistic license that goes into it, but you're seeing the real thing. But ours is showing, we're just showing the portion that our camera is allowing us to see, which is a small portion of the Orion Nebula.
Yeah. So just wanted to highlight that a little bit. I know it's we can't quite do Hubble pictures, but it's great to see the comparison there for comparison's sake.
Someone's asking if there are any planets visible tonight.
That actually makes me want to go back to the stellarium view that we had earlier.
Let me do that.
Let me pull that slide up.
Do you think we can go completely off script and maybe go take a look?
Oh, I don't mind. We got lots of time left still, right? Well, first I'll switch over to this and see if you can get a little sneak peek. Well, you can already see one of the planets here in view. We do have Jupiter in the sky tonight. Now, it is in the sky right now, but it will be setting here, and I don't know exactly when it sets, but in a couple of hours. So if you want to get a good view of Jupiter, now is definitely the time to go out. It'll be pretty much almost due west at this point. Look west, southwest, look up in the sky, it'll be much brighter than all of the stars surrounding it.
Yep. So, you know what? You ask and you shall receive.
Yeah, let's do it. We'll do it. It's close by. Hopefully it's high enough still.
Well,
Might be getting kind of low in the sky. I think it should be okay.
So what I'm going to do first is I'm going to turn the exposure time down on the camera because I know that it's going to be really bright. So this is taking it down to about 20 milliseconds, and when I do that, you can basically only see the trapezium stars.
I might drop the gain.
Yep, I'm going to turn the gain down, the artificial brightness. So I'm going to do that because Jupiter won't need it. All right.
No, it will not.
So then I'm going to go over to the software where we control the telescope, and I'm going to zoom out. And there it is, right there. So let me check the altitude. Yeah, we may just catch it. So let's go.
Good timing, whoever asked that. Good timing.
All right, here we go. And the telescope is moving, and I have to move the roof.
Look at that big thing moving behind us. Now it's really nice and quiet because it uses, does not have any like gears inside it, just electromagnets controlling the map, which is awesome.
Ready?
Yes. Sorry everybody, that was kind of a long roof move, so I did mute us that time so you didn't have to hear that.
All right, let's see where we are with the camera software. Spot on.
Still really bright.
Still really bright, so let's take it down.
Okay, so whoever was asking, it's pretty good, it's a decent view of Jupiter.
Pretty good.
You can see a little bit more of that kind of in effect of the wind, that kind of turbulent atmosphere tonight when looking at something like this that has those really clear defined edges. You can see it kind of jumping around a little bit, right?
Yep. And if I take the gain up quite a bit, actually I'll take that back. I'm going to turn the gain down, and I'm going to take the exposure time way up. You see the other little dots? We've got moons as well. So we do have we've got the focal reducer on right now, right? Is that right?
Yeah.
So you know what I'm going to do is I'm going to, so that we have a lens on the camera that is reducing the size of it a little bit. So should I just go completely off script and take that off for a second? Let me do that. Can you ad-lib for
Oh yeah, oh come on, you know I'm good at ad-libbing. So the focal reducer, the reason she's taking it off is it does limit the field of view that we have slightly. And so you might have noticed that we were seeing 3 moons before. Now the reason we might be missing the 4th is it may just be off view. You can see that a couple of those were really pushing the very edges of the view. Now there is a chance that it is that extra moon might be behind Jupiter at the moment. There's a chance there. Actually, I could check and find out. Jupiter's moons. Apologies for the off to the side searching. Oh, it's a transit. That's why we were only seeing 3.
And I am not getting a change. All right, what I'm gonna do is I'm gonna turn the software off, and then I'm gonna go back in.
Oh yeah, that's right. No problem. I will switch over to our slide view for a little bit, just because she's gonna be messing with that. Take you back into the slideshow here. So one of the planets that we can see is Jupiter here. That'll be the one that you can see with the naked eye tonight. You might see another planet name just beside it though. We do have Uranus up in the sky tonight, but that is one that maybe in the darkest location in the world you could make out with your eyes if you really knew what you were looking for, but I'm not sure I could do it. Realistically, you do need a telescope to really be able to view Uranus. Got it back in focus a little better?
Yeah.
There we go. So those are the 2 that we have up in the sky right now. A lot of the other planets are up mostly during the daytime right now, like Saturn setting either very around sunset or basically right at sunset. Same with Venus, Mercury, a lot of them are right around there right now. Would you like me to switch back to the
Yeah.
telescope view?
Yep.
There you go.
So we've got Jupiter a little bigger, but I need to adjust the exposure time. There we go. That's a little bit better.
Sorry, I think I said the opposite thing earlier. I said that the focal reducer was shrinking it. It's
Yeah,
actually
it is.
expanding the field of view.
No, the focal reducer is
Oh, okay.
shrinking it. I just expanded it by taking the focal reducer off. So this is
Gotcha.
what I just took off the camera. So there's a little lens in there, and that is reducing the size of the of whatever it is that we're looking at, just to see a little bit wider view, a little bit more easily. So I took that off because I don't want to make Jupiter smaller. I want to make Jupiter a little bit bigger.
Right.
So I haven't adjusted the color at all. It is a little bit yellower.
It's looking a little yellow.
Yeah,
tonight.
mainly because we're looking, it's pretty low in the sky right now,
Right.
so it's going to be a little more yellowy.
Right. Imagine sunset, right?
Yep.
Even the color of the sun, right? Something that's so bright does change quite a bit around those times.
So there you go. Not too bad. Not too bad. And again,
I'm
it's-
glad you guys are liking the off-script work in the
Nice.
chat. Hey, we want to make sure that you guys get to see what you want to see. Don't worry, we'll get back to the Orion constellation. Don't worry.
all right, cool.
Well, wow, great, nice view of Jupiter tonight.
Yeah,
huh?
not too bad. Now it is, like I said, it is getting lower. So it's jumping around quite a bit.
Right.
It's yellowier. It's not as great of a view unless it was up a little, as compared to being up a little higher.
Right.
But hey, it's Jupiter. It's cool. It's live. It's not cloudy here. It's not
Yeah,
zero.
that's our little planet
It
view
is
for the
not
night, right?
0 degrees out. We're thrilled that we can show this to you. All right. So I should, actually can keep it here. And if we want to go to, I don't know, what would you like to go? Betelgeuse or one of the
Yeah,
others?
we always could. I think that's a good transition point. We've talked about, we did our off-script stuff. Jupiter's looking lovely tonight, nice and close by Orion. And we've talked about, the birth of stars so far. Maybe we should see a couple of stars that are in action, right? So you take your choice. We can switch to Rigel or Betelgeuse first. What are you
Betelgeuse,
feeling?
why not?
Okay, let's go Betelgeuse
All right,
first.
so let me go to the telescope software. So I'll go there, and I'm going to click that out, and I'm going to go in just a bit. So I'm doing this live.
There you
so
go.
there it is, right there.
Yeah, so you guys can see these are all the controls that we need to control the telescope. So
Yep.
this is the native plane wave interface. So it's created by the company that made this telescope.
Yep.
And then we've got the MalinCam program that's for the camera, and that's all we're
Yep.
using tonight. Really
Shout out to-
straightforward setup.
Shout out to PlaneWave. They're fantastic.
They
All
are
right.
really great.
All right, I'm going to hit go to, and you'll see the telescope moving behind us. See? And I have to go move the roof again.
I will mute again because this might be another long move. I apologize for the silence. All right, and we're back. Everybody's listening in. And we'll switch back over to our live view of the camera.
There it is. Oh, it's not too bad.
Betelgeuse.
That's pretty good.
Yeah, looking pretty good.
And again, actually, you can see that turbulence quite a
Yeah,
bit.
really well here on a
See that?
star, right?
Yeah.
So, taking a look at now this one, the Betelgeuse, one of the most famous stars, honestly, probably in the sky, not just in the constellation. Both this and Rigel, both being the 10 brightest stars that we have in the night sky. And this one, one that has, even its name has inspired so much. So this is one that I think people are very familiar with. It's that top left corner of the Orion constellation. Yep, one of his shoulders there. I guess that's his right shoulder,
Yep.
depending on which way he's facing,
Depending
I
on which
guess.
way, yeah,
But
exactly.
I imagine that he's looking down on us is kind of how I see it. So it would be his right shoulder there. Now, there's a few different things that we might notice here, Now, Betelgeuse is known for being, a star that is relatively close to the Earth here compared to a lot of the other stars in the night sky, right? But you might notice, still looking pretty small there on screen, right? So, what's up with that? Are there any stars that we can make out any bigger than this?
With our telescope, no. With with a really, really powerful telescope, such as maybe Hubble, yes, you can see the disk of Betelgeuse. Our telescope can't do it though.
Right.
So all stars will just be points to a telescope like ours. And the what you're seeing right now is the jumpiness of the atmosphere, the turbulence in the atmosphere. But please note the color.
Right,
Do
that's
you
going to
see
be an
the
important
color?
one, right?
Yeah.
And I think that'll become a little bit more apparent when we switch to another star as well. So there's so many interesting things about these stars, right? And it is a really, I think it's always something that surprises people that it is still these little pinpoints, right? And up until very recently, that was the case for all telescopes in the world, right? There's still very few stars that have been imaged beyond a single point of light. So that'll be honestly a really big step in astronomy, is getting more views of these stars and actually seeing their disks, right?
Yeah, they need to be big. They need to be close, and there are only so many of those that we can look at.
Right.
But there's a really good reason why this one is big, and that is because it is a star nearing the end of its lifetime. It has expanded, and it is a red supergiant star. This star will explode someday. Sometime.
Right.
Put it on your calendar. I can tell you when. I can tell you when. You're going, Michelle, wait a minute. Are you sure you can tell us when Betelgeuse
Right
will
now.
explode?
Oh, dang it. Can you
Oh,
imagine? Can you imagine?
Anytime between now and a million years from now, it will likely explode. So there you go.
So we can see people were actively asking the same question in the chat as you were preparing them for it, asking about Betelgeuse going supernova. And this really ties together this kind of theme of our show, right? Beginning at star birth, ending at star death. We don't quite have the death here, but kind of seeing it in its old age. And this is one that is really talked about so much with it going supernova. And it is for a good reason, right? There are plenty of other stars that we have seen go supernova in the past, some within the Milky Way galaxy, some a little bit further away, right, in other galaxies.
You know what I'm going to do is I'm going to just see if there are any other stars in the view. I'm going to really whack out the exposure time. There is one there. Not bad. Not too bad.
Really brings out the color of Betelgeuse as well.
Yeah, you see that orange color? It's a red supergiant star, but really to our eyes, it's going to be orange. And so all I was doing there was adjusting the exposure time. So I'm taking it down back to Betelgeuse being a little bit more of a point. There we go.
Right, so that exposure time, it might look like it is getting bigger. It's really just extra bright and kind of almost blowing out the sensors a little bit because it's so bright.
We sometimes get this question. Those spikes that you see, are those part of the star? The answer is no. Stars don't have points. That's because of the telescope. So there are struts inside the telescope that hold the smaller secondary mirror. So the light comes in, bounces off the main mirror, goes back up, hits a smaller secondary mirror, which then sends the light through the back of the telescope, and then you can put a camera or an eyepiece or something there. Well, what holds the secondary mirror are these struts, and so the light passing over those struts imprints that pattern of the struts on the light from the star. So the star itself does not have those spikes. That is because of the telescope. And there's nothing you can do about that. You could remove them, but you'd be removing data.
Right.
So people ask that about the Webb telescope as well.
I was gonna say that's a good comparison, and that was something that I saw talked about a lot when the JWST was launched, comparing it to Hubble.
Right.
I believe Hubble has a similar 4 spike kind of diffraction spike setup, whereas JWST has actually 6. It's hexagonal.
Right, and I saw people asking, so wait a minute, why couldn't they have picked like a camera that didn't create those spikes? Oops, sorry, I'm trying to get the exposure time a little bit. There we go. Couldn't they have picked a better camera or something? No, that the light bouncing off of portions of the telescope's mirrors creates those spikes. And so there's nothing they can do about that. That is because of the physics of light interacting with stuff and light interacting with the telescope itself. So they don't remove those, and there's nothing they can do to take those out, right? Or to not have them. So should we go to Rigel?
Yeah, we do have one really good question. Sorry, Jennifer was like in the middle of typing it out. This is a good one. Good question, Emma.
Yep.
Is it possible Betelgeuse has already gone supernova, but we cannot see it yet?
And the answer is
Yeah, it is, technically.
Yeah.
I don't know exactly how far away Betelgeuse is from us right now. All right, quick.
Hang on.
Oh, this is what I already said it earlier. This is what we got Geza in the chat for. Geza,
That's
can you
true.
post in the chat how far away it is? So if it happened within that many years, right, how many light years away it is, then yes, absolutely, it could have happened and we just can't see that yet. So that's a really good question.
It's around 700 light years away. So that means
Pretty close for a star.
Yep. If it has exploded sometime in the last 700 years, then the light just hasn't gotten here yet.
Right.
But 700 years is the blink of an eye when it comes to a star's lifetime.
Right.
So
yeah, like we said, we're like talking about how it's old and it could die in the next million years.
in the next
right?
million, yeah.
So-
So it's not really anything. Unlikely that it has, but you never know.
Totally possible. I mean, again, like there's a reason we have such a huge range, and it's because we're still learning so much about this kind of these processes in stars. They're on spans that are so much bigger than what we deal with here on Earth. And so I think they're all really great questions, and it's great stuff to consider. And I think why people are so interested in Betelgeuse going supernova is because it will be very spectacular compared to other ones. I think I've seen estimates that it could be as bright as the moon in the sky. Like it will be an incredible sight when it does happen.
Yep.
And while Michelle switches the view over to our next star for the night, I wanted to show you. These are the kinds of supernova that we're seeing here right now. It's this is one in a distant galaxy. Oh, sorry, you can't see it on the little screen anymore.
That's okay.
This is in a much more distant galaxy from a show that we did. Actually, we had a live view of this one in a live stream, right?
Sorry.
It's all good. And so this one is happening in a distant galaxy, and you can see this supernova right here. That is one star exploding, similarly to how Betelgeuse will, is completely outshining the entire galactic core here, brighter than an entire galaxy. So you get why people are excited about it and have their fingers crossed,
Yeah,
right?
this is a live view that we showed at our show last summer, so that was pretty fun. Okay, so I moved the telescope to one of Betelgeuse's constellation companions, and that is Rigel. And Rigel is one of Orion's knees. So why don't we switch over to the telescope view? There we go. Do you notice the difference in the color?
I'm curious to see if it's easy to see online, like through the stream and stuff, especially with this. So definitely leave your response in the chat. Yeah, can you tell a difference in the color? It's a little tough.
You know what? I know we weren't going to do this live. I'm going to do it live.
I've got the pictures.
I know.
You're so funny.
All right.
I've got the other one.
In order to see star color a little more easily through a telescope, it really helps to take the telescope way out of focus. And so we talked about this earlier. We're like, no, we're just going to show the pictures. You know what?
We already took out the focal reducer. It's fine. It's fine. Everything's going too good tonight, so. There you go. I mean, I think that's a really striking difference, right? I think, when you have it as a single pinpoint of light, it becomes much more white, right? There's so much light concentrated in that one spot.
Yeah.
When you spread it out a little bit, you can see a lot more of that color difference.
It's a blue-white star, and
Right.
I hope you can see the blue-white color in there. So if you want to see star color a little more easily, just take your telescope way out of focus. And actually, why don't we switch over to the actual...
Yeah, and so we have this one with Rigel here, but if we compare it now to an image of Betelgeuse as well, you can really get a clear idea of that color difference. And honestly, I think even if you go outside and look up in the sky, especially with these two stars, I think you can tell a pretty clear difference between these two, because they do have such distinctly, well, kind of orange and blue colors. I think you can really see them when you look up there.
I love these pictures. These are my favorite.
And they're really cool, yeah. We took these on a night when, like we said earlier, the seeing was really bad.
Yeah.
So, shocker, the best pictures we got were the out of focus ones.
Right, exactly. I'm going to go back to the camera view because I can put the telescope back
in focus now, yeah.
Let's see. And I just shocked myself touching the telescope. All right.
But yeah, I think that gives you a really good idea of these different colors that we can see. Now, folks at home might be wondering, okay, great, stars can be different colors. Mm-hmm. What does that mean? What is making them these different colors?
Star color tells you star temperature. Mm-hmm. And the coolest stars are the reddest stars. And so our sun, for example, is a yellow-white star. And the bright part of our sun that we see on a given day, temperature's about 11,000 degrees. Mm-hmm. A red star, which will actually to our eyes look more orange, it will be maybe 7,000 degrees or so.
I can't find the numbers in my notes, but I think Betelgeuse is like 5 or 6, something like that.
Yeah, something like that.
A little cooler, yeah.
Yep, and
around
then a blue star is going to be several tens of thousands of degrees, maybe 20,000, 30,000, 40,000 degrees, up toward that higher end. So pretty hot for the stars. But yeah, star color tells you star temperature.
Right, so I think that's so interesting. We've learned a lot about, right? We learned about the birth, we've learned about our death. Now we're kind of meeting in the middle, learning about what stages all these different stars are at. I think people might be kind of surprised to hear how different some of these different stars and star systems can be. And actually, that reminds me, I almost forgot before we left Rigel.
Correct.
We should up the exposure time on this one too, because you might notice something a little bit different than when we upped the exposure time on Betelgeuse. Hopefully the resolution is good enough on the stream to be able to make this out. But we've got that really bright Rigel there. But you might notice is like, oh, what's going on? Does Rigel have a tail? No, not so much. Stars are all going to be pretty much spherical. But it has a little friend. Now, this friend is not just a background star, right? Sometimes that might happen. They could be real close together, but they're in very different places in the galaxy. These two happen to be actually right next to each other.
Exactly, yep. So stars many times come in multiple stars in the system. So Rigel is one of those. Mm-hmm. And we can see, I hope it's coming through on your end, on the viewer end. So let us know if you're not seeing it.
if it's tough to make out, that picture has a pretty clear view of the second one there in sight. But I think it's more fun to see the live one.
Yeah, it's a lot of fun.
And so I think people would be really surprised to know like just how many of the stars out in the sky are actually binary systems. Binary stars are a really common kind of sort of target for amateur astronomers and in their hunt to see how close of a binary they can split. This being a pretty darn close one between these two Rigel ones, it's really tough for us to even make out the second one without washing the camera out too much with the brightness of that first. And actually upon, further investigation with this star system, they have discovered that there's actually even more than two stars there, right? So visually, even through a telescope, we can only make out those two, but there are some other kind of unique techniques that astronomers can do that will help discover other, binary stars or things that might not be directly visible to the eye through the telescope.
Yeah, basically you can look at the patterns of light that come to us, the spectrum that comes to us from these stars, and the patterns of light are going to be basically determined by what the star is made of, and it's these patterns that we look at that show us different wavelengths of light. Well, put it in a nutshell, when those wavelengths patterns change, when the wavelengths that we see are not exactly what we expect for what we know that star is made of, then we can actually see those patterns shifting and moving and in the light that comes to us. And depending on how long it takes those patterns to shift, that tells us that there is something there causing the star's light patterns to shift. And because they're just going to shift all by themselves. Something has to cause it. You might have an unseen or a companion star, or more than one, that might be gravitationally tugging on that brighter star. And so we can infer from the shifting patterns of light from the main star, we can infer that there is at least one or more other stars there doing that. So it's really interesting that we can do that and not see that actual star necessarily.
Right, and I love the example that you used earlier relating to cars moving away, moving far away from you, right? So you might not, maybe if a car's, way down the street and you can't see the two cars, if you had, okay, let's compare our telescope to maybe a really powerful microphone that could hear them all the way down there. You've had cars drive past you really fast, they start deeper and then it gets higher pitch, right? So if you had a microphone listening to the sound of those cars from a mile away and you listen to it and you hear it one getting higher pitched and one getting lower pitched, okay, well now this gives you an idea of which direction they're moving, that kind of thing. Very similar technique happening here, but instead of with sound, we're doing it with light.
Correct.
And we're basically using, I did want to show this other image as well. This is kind of related to the tools that we are using to split this light. This is an image taken of, this was a Polaris, I believe, right? The North Star, with something called a spectroscope attached to the telescope.
Yep, so we have a special filter that we attach to the camera. So it was this camera that we've got on the telescope right now with a special filter that splits the light into its component colors. And so the brighter star in the picture is Polaris. The other one...
Yeah, well, would you look at that? It's a binary too.
Yes, it is. Polaris is a multiple star system. And so that you can see the light of the spectrum, the pattern of light from that particular star, from Polaris. Now, we do have it was really bright. It is really bright, and so some of those patterns kind of overlap.
Yes, so this is not a research level image of this kind of stuff, right? And they're not, usually when they're doing research stuff like this, it's going to be, a computer taking all that data out and really paying close attention to the exact values. But I thought this at least demonstrated how we are able to stretch that light out, see all of the component parts. This helps us find out what kinds of stars we're looking at, right? What kinds of gas are contained in there.
What we would be looking for is dark lines embedded within these colors, and it's those patterns of dark lines that shift. The star's light stays the same. It's the patterns embedded within that light that's what shifts.
Yeah, there's of course lots more to learn with the spectroscopy, but we'll leave that for another day. We'll leave that for another day because there is a lot.
All right,
it's very useful stuff.
Should go back to the telescope view.
Yeah, let's take it back to the telescope view for now.
Let's see. Let me go back to. Let's go back to. You want to go back to the Orion Nebula, or
we could always do that, or we could. We were looking at we were talking about that cluster too, the open cluster up at the top. But I don't know how easily we'll be able to make that one out. It might be kind of hard from over here.
That's true.
You're welcome to choose whichever object you like, of course.
Let's see. I'm thinking. I think, let me get rid of this box right here. How about...
Actually, maybe...
How about...
I forgot. I was trying to keep it a surprise for everybody, but then I forgot that you were looking at that screen too.
How about that one? How about we go, why don't you start us off on some of our history collection.
Sure, I can talk about this a little bit while you work on getting this in.
I'll get this in
all
view,
lined
make
up
it all
and stuff.
look real pretty and everything. So
yeah,
go ahead. I may have to move. I'll have to move the roof, but yeah, we'll wait.
No biggie.
Go back. Go back. And good. Okay. Ready to go.
So one segment that we usually like to have in this show is something called Collections Corner, where we highlight some objects from our collection. All right, we're back. So Collections Corner is where we like to highlight some objects from our collection related to the topic of the show tonight, and it was just such an easy one tonight looking at the Orion constellation. We've got so much awesome art related to this part of the sky. So starting with really the most classic view of Orion, this is from a British encyclopedia from the early 1800s, and this really gives us a better idea of kind of the classic Western world view of the constellation. We can see Orion the Hunter here, the way lots of his stuff is depicted. We can see that club. Here the shield is depicted as a lion's coat, but it's often depicted as a shield too. The club can be made of brass at times. We can see the sword down here beside his belt, but that's not necessarily how everybody looks at constellations, right? So a lot of different astronomical cultures around the world have viewed constellations in very, very different ways. Now, some of that has kind of melded together as time has gone on and we live in this more globalized world, but we have some artifacts from some other parts of the world that showcase how they view the sky a little bit differently. And this one is an awesome Chinese star map. This is called The General Map of the Stars Gathered in the Immense Sky. This is also from the early 1800s. Now this is a more complete star map rather than just focusing on Orion. And this actually dates back way before the creation of this particular print in the 1800s. This is based on the Suzhou chart that dates all the way back from the 13th century, the 1200s. So this is really, really old history here, old astronomy history. Now, to be able to get a better view of this part of the sky, we'll start zooming in. We can see the sky is broken into what are actually called different mansions here around the outside. These were used to track, they're almost like big wedges of the sky, and these were used to track the movement of the moon, very similar to how we use the zodiac constellations to track the movement of the sun. Now if we zoom in a little bit more, we can see a pretty familiar friend here. Here is what we know as Orion. Now, of course, all these stars are the same as we have in our sky. There's nothing different there, but you might see they organize them a lot differently. Michelle, something that I love in this star map is how many circular constellations there are in Chinese astronomy at this time. They also often break them up into much smaller groupings of stars than what we do. Now, it's no surprise that, you know, Orion's belt and his shoulders and stuff are going to inspire similar kinds of shapes in the sky across cultures, and we can see that that's absolutely the case here. This one was actually just known as the Three Stars Mansion, really straightforward. They said, look at those three stars, so nice and close together.
Yep.
But then some of the other parts of Orion are viewed as different objects. We've got the head of Orion. For us, it's actually a different constellation called the Beak. We can see some of these down here, these squares down here by Rigel. It's the Jade Well down there. So we can see that they're finding some different shapes than what we are, but my favorite part about this one, this will be the last thing before we go to our last object for the night, is there's one story that is particularly similar between Chinese astronomy and, you know, more Western European astronomy, and they actually have like very different histories, and it connects to the fact that Orion and the constellation Scorpius are not up at the same time. And so the story in Chinese astronomy is that there was a very famous emperor back hundreds of years ago who was having, his sons were bickering too much. They were fighting all of the time. And the only way he could get them to stop was by sending them to the sky and trapping them in these constellations. And these are two constellations that are never in the sky at the same time.
Right.
We've got the exact same dang story with those two constellations, or at least those two parts of the sky, right? Different constellations, but these kinds of connections that we're noticing together, which I think is just great, that across time and space, that was on purpose.
Yeah.
You know, we can still have these connections. So I learned that while researching for this show, and I thought that was a great story to connect them together.
Well, our last object for tonight is something that we weren't sure if we were going to be able to show it to you, but we've got the moon. And the moon actually sometimes skims just the top part of Orion's upstretched club. It doesn't tonight. It's not, the moon is not against those stars. That really won't happen until about the early 2030s when we get the moon going a little farther south in the sky to be able to do that. But this is a live view of the moon. If there's any doubt, then I can take the hand controller that we use to move the telescope, and I'm going to show you while I do it. So there you go. I'm going to tap it. See?
There you go. We're looking around the moon.
And, oops, I shouldn't go too far.
Now, I will say, folks that come and visit the observatory get a real kick out of the fact that we really do just use a Logitech Bluetooth video game controller to move the telescope around.
That's what this is. So, yeah.
Always fun to put that in the hands of folks that come and visit us on Wednesday nights.
I did put the focal reducer on, and I did change the color aspect of the camera to gray. Just so it, because I was using the color camera, it was already set with other settings. So to speed up the process, to show you the moon as you're used to seeing it, I turned it on the grayscale part right there.
Yeah, sorry for leaning in so close,
Yeah,
but I'm
that's
just
all right.
trying to get a better view of this. It looks so lovely.
Pretty cool, isn't
Yeah,
it? So if I'm
Never
not
gets old.
Nope, never gets old. So if I'm not mistaken, this is the crater Tycho, or Tycho, named for Tycho Brahe. And so we've got just an amazing array of craters. So I'm going to try to go upward here. This is hard to do because
the controller joystick directions don't quite align with how the telescope moves, which is confusing.
Nope.
You got to kind of
So-
hold it sideways
There we
and
go.
upside down a little bit.
so I'm literally holding it sideways.
So one thing you might have noticed as we have moved around looking at the moon is that kind of that beginning view where it was sort of going into the shadow, that is called the terminator line. And this is the line where sort of the moon is shifting between daytime and nighttime, right? You can imagine it's almost like sunset there. You can get a lot of really good detail in the craters and seeing all of the mountains over there. Because of the fact that it is sort of that time of day there, right? I always compare it to, hey, when it's sunset here, we have nice long shadows because the sun is low in the sky. Exact same thing on the moon. Look at how many more shadows and how much more detail we can see in those craters.
Exactly.
They're near the terminator. Oh, look at that cool
That
one.
cool.
Down there.
Oh, that's
wow,
so cool.
That one looks great.
All right, we hadn't scripted this, if you couldn't tell. But I'm gonna turn the exposure time up just a bit. Whoops, I want to do it too much. There we go.
Wow.
And I'll turn the gain up just a tiny bit. Not
Just lovely.
Too much.
If any of you guys were wondering, no, it never gets old.
Nope. Nope.
It's
Nope.
always awesome.
And yes, we do write an entire script.
And we-
Actually, Hunter writes an entire script, and we usually end up talking maybe 30% of it because the rest of it is us just.
We got all the topics
We
in at
did,
least.
but
Yeah,
we're
we
staring
did.
at the telescope view going, oh my God, isn't that cool? So yeah,
Hey, if
we
it
do
was
that.
cloudy, I'm sure we would have followed the script to a T. But when we
Exactly.
get a great night like this to observe, we might as well show off as much as we can.
Exactly. I hope
Well,
hope
while
y'all
we
are
admire
enjoying
the
this.
moon here and look around a little bit, I want to let everyone know that we'll be signing off here soon. So if you have any last questions, to post those in the chat.
Yep.
I want to say a big thank you for joining. If you're ever interested in coming and looking through this telescope yourself, we have it open on every clear Wednesday night. We're open until 10 o'clock. We open at the earliest 7, but sometimes in the summertime it's when it gets dark out. If you want to get more information on whether or not we're open based on the weather, what time we'll be opening and things. Wow, that moon's bright.
Sorry.
It's okay. It's like really close and actually really bright. So.
Yeah, it is.
You can stay updated on when we'll have the observatory open on our Facebook group Scopes with the Adler. You can also stay connected with all of our telescope observing events, things like Scopes in the City. We've got one coming up just here on Monday
Yep.
of next week, so that's a great place to stay in touch with everything observing related that we do here at the Adler.
So you are going to be at that Scopes in the City. Where will you be? You're going to bring a small scope out, and anybody coming by can come take a look.
Yeah, we will
Where
be down at the Vodak East Side Public Library branch. So down on the south side of town, pretty close to the Indiana border there. We'll be there. Come and say hi. Keep your fingers crossed for good weather. But yeah, check out Scopes with the Adler so that you can stay in touch with all of those kinds of things. Now, if you are joining us from anywhere, not in Chicago, you're not visiting anytime soon, of course, hit subscribe down below. Stay up to date with all of our online content. There's a lot of great stuff going on as well, including our next Sky Observers Hangout, which is a pretty exciting one, right?
Yep,
Do you want to tell them about what that is?
I will. And so while I do that, why don't you move the view around
Oh
just
yeah,
a
I'll
little
look
bit.
around a little bit.
And so
Why not?
our next show will be Sunday, April 7th, 2024, a very auspicious day. It is the day before the major solar eclipse coming up on Monday, April 8th. So Sunday, April 7th, we will be coming to you live from the steps, weather permitting, of Shryock Auditorium on the campus of Southern Illinois University, Carbondale. So it will be at 7 p.m. If you're gonna be in Carbondale to watch the eclipse, come see the show. We would love to see you. We'd love to see some of the faces that are behind the YouTube screens. So we'd love to have you come and say hi and see the show live. And weather permitting, after that show, there should be some scopes out for folks to check out for about an hour or so till 9 p.m. So that show is 7 p.m. At Shryock Auditorium, outside, weather permitting, at Southern Illinois University, Carbondale. We're going to talk all about the eclipse and get everybody all set for it.
Yeah, so it's gonna be a really fun weekend, and
exactly.
Jennifer's gonna be posting a link in the chat to our kind of complete eclipse guide that has information on not only our Sky Observers Hangout, but also the observing event that'll be going on here at the Adler on the 8th as well. So all kinds of great stuff. Good question. Unfortunately, the dome will not be open tomorrow night. Does look like it's going to be totally cloudy tomorrow night.
Yeah.
Winter's kind of tough. We're getting into some better season, so hopefully we'll have more open nights soon. But even more reason to check out Scopes with the Adler and stay connected with us there.
Yeah, we were really happy to show you Jupiter and the Moon tonight, because it would have been what we would have been looking at tomorrow.
And maybe the Orion Nebula too.
And maybe
Probably
the Orion
pretty much
Nebula
those
too.
exact objects. So you got a great little sneak peek of what we would have been looking at anyways.
Exactly. So we hope you really enjoyed this. We certainly did. We are thrilled it was clear tonight. And we
were
loved,
stressing out all day looking at the forecast.
We
thought it was going to get cloudy right at 8. So this has been great fun.
So it was great. So thank you everyone for coming. We hope to see you at the next Sky Observers Hangout, Sunday, April 7th. 2024, 7 p.m. Central Time. Send us your questions in the chat if you're not with us live. If you are in Carbondale, come see us. And we will see you next time. Thanks a lot.
See you next time, everybody. Bye.
Bye.